All right, welcome to the CS350 section 6. This is number 11. Today is March 27, Wednesday. So before we get started, if you, some of you have already done this, but as usual, if you could give me a private chat with your name and ID, I'll take that as attendance. Is there any question before we get started? Well, feel free to ask along the way then. I'll take that as everything's okay. I just wanted to say that Lewis is off starting tomorrow, Thursday, all the way to Monday for Easter. Today being Wednesday, we do have a class. So that's pretty much it. Maybe a word about week 11. And so this week is 11. That means we're pretty much heading toward the end. As you can see on my blackboard here, make it a little bit bigger. You can see that we have 1, 2, 3, 4, just about a month to go. So the end is near, and week 14 is where we do the sampling of the building of operating system part 1, and then week number 15 is part 2, and then that's pretty much it. Week number 16, we don't have much going on other than the course evaluation. So that's pretty much it. Next 2 weeks, 11 and 12, although I lumped this together because they have just one particular topic, which is the IO or the file. So I may split this out by next week, but that's pretty much it. So hang on there, and the end is coming soon. Okay. So for today, what we have planned is the mass storage worksheet and the lab. Okay, so without further ado, let's take care of that. In the instructional material, here is the mass storage worksheet, and then here is the lab. I posted the demo video, which I'm going to go over, so this may not be as necessary for you. This was provided for the section 1, but I thought I'd give it to everybody. But here's the lab instruction, and you have options of doing 1 or 2, okay, which I'll go over that today. So we'll see how time goes. We may be able to finish at 7. If not, then we'll take a break at 7 and then kind of continue right after. So if you come on up to the top, click on the worksheet question here. Here it is. This out of the way here. And if I enable it, so this is it right here, just the 5 questions. Okay, so that should be pretty not too long, but I am going to pull up my answer sheet here. So if you give me 1 minute. Okay. Here we go. I'm going to remove this and then do the this one because it has all my notes. Okay. So this is in the same order as usual. So let me begin by clarifying the question, the comments here, or the vocabulary mass storage device. we used to not have this term. We used to just refer to a particular type of storage device. But we use this term more frequently and prevalently in textbooks and articles to mean any non RAM device that can hold a large amount of data. Okay, so it can refer to a hard drive most of the time, which is probably the case for most of the individual users, as well as, still a lot of the companies would use it. So, that's pretty popular. And then SSD, more of a case for the individuals than the companies, but still it's just pretty common. More for the old style tape drive. Here's a little bit, portable ones, a USB drive, which tends to be larger than the RAM. And then you have a few other stuff, but any one of these is okay. And the reason why we need to talk about this, which I did not put it in here, so let me kind of bring this here a little bit and kind of talk about that a little bit. So where's my paint? Here we go. So the reason why we talk about the mass storage device is because, let's see here, is for, when we talk about the, maybe it's a little too thick, a memory, we usually talk about the main memory, and this is the RAM. Okay. So here is the RAM, and this is what the CPU looks at to get the program, because in here is the processes, right? But these processes are not present when the computer starts. They all have to come from somewhere because the RAM is volatile. And so here's the mass storage device. Even the OS needs to go here. Some other system apps needs to be going here. And maybe even virtual memory that we carve out needs to go there. And the user app needs to go here. And so the way they go here is the reason why we need to talk about the mass storage. Okay, so we'll actually be doing how we're going to do this today. All right, and the way that we go about doing this is, you need to say something. How are we going to do this, right? What is the method? And so what is the algorithm here? And so we call this a disk scheduling algorithm, or simply mass storage scheduling algorithm. But I am using the disk scheduling algorithm here today because what is most popular and common form of the mass storage is the hard drive, right? So we are going to look at the algorithms for this guy, all right? That's what that is. And then, as expected here, what are some common disk scheduling algorithms? You've seen some of these before, such as the first come, first serve. Whenever we need to move a portion of data, whether it's an application data or otherwise, we need some algorithms. And, some of them are pretty common and they show up. So this one here says, first come, first serve. And what this means is when the operating system is loaded, initiated mechanically, then whatever the remaining portion is here, whichever comes first, whichever request of the application comes, is the one that we're going to service them by putting into the RAM. There are a whole bunch of other variations here, but we'll look at some of these, okay? So without a further ado, and these are only referring to the disk scheduling algorithm. There are other algorithms that are meaningful if the mass storage device is the SSD or tape or otherwise, okay? All right. So let's look at the first one. It says, given the following scenario, right, draw the movement diagram of the arm and or the platter rotating, and calculate the total head or the arm movement. Assumption that we have a hard drive, right? So it tells you, and this is one of the, as you can tell, a certification test question on one of them tests. If the disk is disk head is initially located at track 32, so you have a, let's do a new one here, a new save. So we have if it's a hard drive, and we'll have some platters, and we got these tracks here, right? And you got these sectors on them. So let's say this track here at 32 or whatever, right? And the arm is moving in and out like that, or and then the disk spins this way, or whichever direction. And then here we'll say, let me just start over again. And so what you got is over here, you have this series of storage here, and the portions here is a 98 and 37, 14, and they're all coming in here, okay, in that series, 98 first, 37 first, kind of like that. And so we need an algorithm, a first come, first serve, by taking care of these requests and putting into the RAM. Okay, so 98 goes here, 37 goes here, and kind of like that. And we're not talking about, what if it's full and stuff like that, okay? So anyway, and by the way, if you're kind of curious as to where is this, right? This will be in the OS buffer would have it, or we can leverage the part of the RAM as a process table, which will be shuffled, but it is not actually in here finally, right? But anyway, so if these guys come and we're using the first come first serve, how do we figure out the total distance of the arm or the head movement? Okay, so that's a question. And so the way you do them by hand, which I already showed it here, but I'll kind of do it on the side a little bit here. So what you do is you write down you draw by hand or however you usually draw. Let me see if there's a chat. Okay, that just not. So what you do is you draw a line. Oops. A decent line, right? It's not perfect, but pretty straight line. And then you start marking from 0, and you look at the sequence here. You don't need to go to infinite, but you need to look at the largest number, 127 in this case, and then mark something larger that is even. Okay, not 127 or 136 or whatever, but some even number. You can do 150 or 200 or whatever. But this guy happens to write 199 or 200, counting from 1 or whatever. So you can say, here 199 or 200 or whatever is, you like it better. And then you take this number here, 98, all these numbers, and mark them over here reasonably. Okay, so you come to the middle before you mark them. You kind of eyeball it and say, this is my 100, right? Remember that. And then first you take 98, so it should be sort of before that, right? So you kind of put a dot over there or a little line there and say 98. Okay? And then you take the 37, so this should be like 50 here, so about maybe something here would be good. So I'll do that and say this is 37. Okay, and then take 14, so 14 should be like here somewhere, so I'll say 14. And then 124 should be here somewhere, right? So I'm gonna say 100, 150, 124 is like here. So 124. And then 65 is in between here, maybe like here somewhere, right? 65, and I see 67. So I'm gonna say 67 here, okay? And then you're starting at, they tell you it's gonna start at 32. So I'm like right here, right? So I'm starting right here, 32, okay? And you can say 32. And then what you do is, because this is a first come, first serve, I'm gonna look at 98 here, right? So I'm 98, 37, 14, 124, 65, 67, right? So I see this first, I'm gonna take care of that. So from here, you go toward where the 98 is. You don't go straight, because otherwise it'll go back and forth and it'll mess up. So kind of, decline a little bit, go like that, right? And then put a little dot there and then make sure it kind of lines up. So we're done with this one. And then do the 37. So it's gonna go a little bit here, right? So I'm gonna put little dots on this side. And I'm gonna say, maybe I'll go this way this time, right? And then kind of go like that. So it'll be 37, right? So I'm done with that, and then it'll be 14. And then, this guy over here is like here. So I'm gonna go this way, and I'm done with this. And then 124 is like way out here. So I'm gonna go like that. And over here. So I'm done with that. 65 is over here. So I'm going to go 65 this way. I'm done with that. And then I need to do 67. And then 67 is like over here. So I'm going to go kind of like that. Okay, I'm done. So that's how you do it. To draw the drawing of the lines. Okay, so this will kind of give you a pictorial or visual representation of how the head movement is going to look like. And then the next step, the third step, is to figure out the distance between, total distance by adding up all the segments. So you figure out the distance for this one is from the end, 98, minus the beginning of 32, right? And then for this guy here, from 98 minus, what is it, 37, right? And then for this guy here, 37 minus 14. And then this guy would be 124 minus 14, right? And then this guy here would be 124 minus 65. And then this guy would be 67 minus 65, right? And then you do that, and then just add them all together, and it should come up to be 321. If you look over here, this guy did 32 minus 98. If you do it the other way, if you do it this way, not like the way I did it, then you're gonna get if you do like 32 to minus 98, that'll be a negative number. But all this distance is positive. So we are interested in only the magnitude, right? The absolute value. And so make sure that you get 321. Okay. So does that sort of make sense? All right, I take that as a yes, things okay. So let's do another, and this is one that we're gonna run the program. So using the lab, all right? So I'm gonna move on to the next one. And here, I'm going to start a new one here. Okay. And so here is the question. Considering this same thing, here's a list of the IOs, which is a 47 and kind of like that. But this is looking using the C look scheduling algorithm. And I'll talk about what that is. And the initial starting is at 63. Okay. It also tells you that the head movement is for servicing these requests is always toward the larger number. Okay, so let me write that down here. So we have a queue, right? And then it starts at 67, 63, I should say, right? Start over. So we have a queue. And it starts at 63. And then we have a C look. and then larger number surface. Okay, and the question is still the same. What's the total head movement, right? So the way you do them is kind of like this. All right, so let me make that a little bit bigger for you, right? And then I'll just kind of try to do this. Maybe I'll just kind of talk about here, okay? So that way you'll see it a little bit better. So what you do is the C look. What this guy is saying is you look and see which one is going to be my next service call. If I start at 63, what is my next greater number? And so if you look at this list here, out of these, the one that is closest, larger, is 87. But in order to do that, what needs to happen is you take the Q and then you sort them. And then you have a sorted list, and then you have your starting point pointing at 63. And you go down the line of the sorted list. Because down the line is a larger number, smaller number, right? So in that way, you don't have to be like comparing and looking every time. So once you sort them, it'll be easier, okay? So now you have a sorted list. So it'll be 87, 92, 121, and 191. And you service them one by one. And the idea is that you move in only one direction rather than go zigzagging, okay? And whether it's better or not, we'll have to see. So you go through all this to the largest number, which is 191 here. But then when you get to the largest number, because you have sorted it, you don't need to go anymore. What you do is circular look is what we're looking at. So it goes back to the beginning, all the way back. And in this case, you're going back to the smallest number. So here, this goes down and then goes back up again and starts from the top to the bottom. And up to 63, but not including 63 because that's where we started at, right? So that's pretty much what we're doing here. And so starting from the lowest number, in this case 10, 11, and 38, and 47, and you're done. Okay. So and then the next step is to figure out what the total a head movement is, or the distance is, by adding up each one of these small sections. But you do have to count this long distance here because the arm is moving, right? And so you add them up all that, which this is kind of a huge, and you come up with a 346. This number is not to be compared with the one we did before because the Q's are different. If you're going to compare the same thing with different methods, then the Q has to be same. All right. So, but anyway, this is how you figure out the number. Well, so that's pretty much it for the worksheet. Okay. But before I go on, let me put on some questions here. So let me start anew. Okay. So my first question is, so in terms of C look, can it be improved? So that's a question that I'd like you to think about a little bit. Maybe feel free to answer in the chat or say something. Or maybe, is it any good? Well, maybe this is okay, but I see a waste. Right, so this here is a little bit of waste of having to go back, right? I think I see some. I seem to have a longer head movement. Well, we'll have to see and compare using the same cue but with a different algorithm. But it seems that way from what we have. Yeah. So yeah, the massive jump. We you have to go back. All that may not be efficient, right? So maybe if we can improve, and there are a whole bunch of algorithms here. So instead of like going here like that and then having to go back all the way there and then come back, maybe if we could do it like this way, if we go this way, right? But instead of going back here, maybe if we go this way and then that way, I don't know if that's going to save, definitely this is going to save a little bit of time, but I don't know how much it's going to save. But so the point that I'm trying to, make you think about is, there seems to be some improvement that we can make, right? If we had the, for the first come, first serve, and if we had, I'll just use a different one. So if we had a first come, first serve, we had one of these like zigzag, kind of like that, right? So maybe you can improve on this one if you kind of knew, and sort the list, and then maybe make some sweeping, movements or whatever. But that certainly could be improved. But let me make a few comments about all this, okay? And so let's do another one. So number one, which is not in the worksheet, number one, these numbers like 346 or 321, whatever, what does that really mean? Right? It means the number of head movements, right? Well, so what does that translate to anything that we care about? I mean, who cares about how many total movements are there? Nobody's talked about this, right? But this is only meaningful and relevant if it translates to time. Okay, how long does it gonna cost me? So when you want to service this queue, is it like going to be 0.1 second? Well, then it doesn't really matter, right? But if it's gonna take like 4 seconds now, but maybe, right? So maybe this could be an issue, right? So unless, and all this movements here depends on the exact device, right? So we don't, not knowing what kind of a device it is, how fast the platter is turning, and some technical and mechanical specs, it's hard to say. But in general, as the number of movements increase, time also increases. So that is a general a trend, but not necessarily. We just need to know and test it out in terms of the times. Okay, so that's number one. Number two, which is a sort of related to it. So in terms of number two, no one really cares. There is no job that you will find of becoming a disk scheduler. Everybody's just using some, and maybe first come, first serve, and just pay the cost of in terms of time. And why is that? Because there's an assumption here that the queue is whatever, right? But this queue is not fixed. It changes, right? So you don't know which direction it's going to go. That's the real problem, right? And so it is hard to figure out and test. And so if you are using a first come, first serve, the general tendency is just put up with it. If that causes you too much trouble in terms of time, then maybe you look at it. But most of the time, no one will pay you money to improve on this strategy. Because by the time you get it, it's probably useless. Okay, but the reason why we talk about this in the class is because you need to kind of know about it, right? and be able to say something when interviewer or somebody asks you a question. Okay, it's not good enough to say, well, nobody talks about it anymore. Well, do you know anything about it? Then you have to be able to say something. Okay, but now I told you everything about it. Any question about the worksheet? All right, so let's do the lab. So the lab portion, if we go close that out now and go back to the here. So here is the lab, and if you look at the instruction lab, it is really a simple, a brief document. So if you open this up, basically all this is saying is, run the disk scheduling program, do one of those two. It's just the only one. Okay, so going back out here, so I'll do the first one. So you can do this option, Python code, or you can do this one. So I'll do one at a time. So if you want to do this one, all you got to do is just click on it, which will take you to another page. And all you have to do is just grab it like usually the way we do it, copy it, and then you can just go to the any online Python compiler. So usually I think I go to tutorials point online compiler. That shows up, and so I'm just going to click on that. And when it shows up, all you have to do is just paste what you copied. Bam, here you go. But before you run it, make sure you kind of look at it. And here it says this is a disk scheduler program in Python. This is only for the first come, first serve algorithm. And I have fixed the size of the queue to be 6 by using this array here, 198.37. It's the same number that we used for question number 4. Okay, so and then the starting head point is at 32. So I'm just kind of mimicking it, right? So if you run this program, you should get the same answer. Okay, so I'm just going to click execute. Bam, here we go, and you should see here the total number of operation is 321, and then maybe I don't know why this is kind of like not coming out well. Maybe if I run this again. Yeah, maybe but anyway, so this should be, kind of like this. 12, 124, 65, kind of like that. So you should take a screenshot of this and make sure that you got the right number, and you can be done. Okay. Or if you want to say, well, that's just too childish, I'm insulted, I want to do the other one, I'm in the computer program. So like I may have mentioned to you, all you need to do is to, go to this source instruction. And this is not mine. This is already posted for publicly for people to use. And here's a disk scheduling algorithm in the GitHub. And on the bottom, it tells you how to set it up. Okay, so all you got to do is just follow this step, and you can run it on Git Bash or whatever you want to use. Okay. So, but if you say, well, so I want you to kind of try this, if especially if you're a CS major, and go through the process. But if you say, well, since you already posted the instruction here to do that, let me take a look at them. So if you click on this, and you can look at it. And you will see that I give you some, detailed instruction on how to do it and how I set it up and stuff. But basically, all you got to do is go to that website that I showed you and run this program. Okay. So I'm going to do that. And if you look at some of my notes here, I put my note on here that my program is installed in this directory. So I'm going to show you that you can run this program on either the Git Bash, which is coming up in a sec. Where did it go? Oh, Here it comes. So you can use this guy here, I don't know. So you can do that, right? Or if you say, that doesn't look very inviting, I'm going to run my, let's see here. By just Windows command prompts. So you can do that, right? CMD here, run that. And this guy comes over here. That looks a little bit more, meaningful or whatever, or if I make it a little bit bigger. And so this is where you start, okay? So, and wherever you end up installing your program, and so mine is installed in SKIM2, so it'll be, wherever, your name is probably. So I'm already here, right? So I need to get into to this directory and see if I'm going to actually have it or not. So I'm just gonna put this guy up here. Move this guy out of the way a little bit. This way so you can see both. And so I'm going to do a dir, and here it is, right? So you see that I do have this directory. So I'm going to need to move into that directory, right? So I'm going to say cd disk scheduling algorithms. There we go. So there it is. And if I clear this out and do a dir, I do have a program here somewhere, handle.py. So all I need to do is just run that, right? So I can say Python dot handle.py. Okay, so and then just press the enter. Bam. Oh, no, let's see, what did I do? Maybe I mistyped. Typing is important. There you go, and press enter. And then it's going to take a few seconds, but you will see that this interface guy coming up soon. All right, so let's give it a sec. Bam, there it is, right? So let me move this out of the way and move this also out of the way. Let's see, before I do, I need to, okay, so I want to move this guy here, and I want to run this program, right? So you just need to type in, because the initial location of the head is at 32. Before I do, let's see here. What did I do? There you go. No, not that one. Here it is. So, since we're using the first come, first serve, here's a drop-down menu you can click, and then pick any one of these that you like, okay? But we're using first come, first serve, so I'm gonna pick that. The first number is a 32 because that's where it starts. And then all you need to do is just type in this series of request numbers separated by comma. So I'm gonna type in 90, 98, 37, 14, 120, 124, 65. I can read 67. Yeah, I think that's it. 98, 37, 14, 124, 65, 67. And all you have to do is just click OK. Bam, here. So what you're looking for here is two things. Make sure that your number matches. Okay, so in case that you can't see this well, I'm going to copy this. Okay, and then make it a little bit bigger for you. And so make sure that you see this number right here is the matches 321, and that was the answer. Okay, and then if you the line of the horizontal bar that we used was in the vertical. So if you don't like this, then maybe what you could do is you can you can, copy this, maybe go to the paint, do a new paste, and then I don't know if there's some way that you can, to the right, yeah, I'm not sure, but that's okay. So you can just take a screenshot of this and that should be okay. So we use the two different programs to run a disk scheduling, one by Python and one by a command prompt or Git bash or whatever. And this one seems to give you, this one does give you a lot more options in terms of scheduling. So it may be worth your time to kind of try to get that done. Okay. Any question about what I just did for the lab? So, all right. So let's then wrap it up. If you have any questions, feel free to ask me, email me. So let me close this guy out here. Go back to the, this should make it a little too big, so let me make it a little bit smaller. So wrapping it up, today is the week 11. We have no school from Thursday to Monday for Easter. And what we did today was to go over the mass storage worksheet, talked about what it is, why we talk about it, and worked on calculating by hand how to figure the total movements. And then we also did the lab on running a program. So for this one, just to remind you that you just need to do one of the two, not both. But you can do both if you like. It doesn't really matter. So next week, we will come back, not come back, we'll be on week number 12. So it may stay as it is, or it may be split out so that it'll be, similar to the other formats. But that's pretty much it. Think so. Unless there's any questions, have a good rest of the evening and have a good Easter. I'll see you all next week. Take care. Bye-bye.